let's talk about aquaculture, fish farming. It's a huge part of how we get the seafood we all love. But behind this massive industry, there's an equally massive problem hiding in plain sight. A problem with waste and, well, a whole lot of water. Okay, so to really get a sense of this, just look at this number, 20,000 liters. That is how much fresh water it can take in a traditional fish farm to produce just 1 single kilogram of fish. In a world that's getting thirstier by the day, that number is, well, it's just not going to work long term. And, that incredible water usage, it's really just the tip of the iceberg. It's not just about the water going in, it's about what happens when it goes back out. So think about it like this. Old school fish farms are basically open flush systems. They have to constantly push fresh water through to wash away fish waste and leftover feed. All that dirty water full of toxic stuff like ammonia often gets dumped right back into the environment. Plus, just imagine the cost of pumping and managing all that water. The industry has been crying out for a smarter, cleaner way to do things. But what if we could flip the script? What if we stopped seeing all that fish waste as a problem we need to get rid of and started seeing it as a resource? As food? Well, that is the absolutely revolutionary idea behind something called Biofloc Technology, or BFT. So what in the world is a biofloc? Okay, forget those sterile, clear water fish tanks. I want you to imagine creating a rich, bustling, living ecosystem right there inside the tank itself. Bioflocs are basically these little floating communities. These clumps of good bacteria, microalgae, and other tiny critters all working together with one mission: to devour waste. And if you zoom in and look at who's actually living in this microbial city, one group completely runs the show. Yeah, a mature biofloc is a whole complex world, but it is dominated by bacteria. 70%. These guys are the powerhouse. They are the engine that makes this entire system go. And this quote from Robles and his team just nails it. The whole point of BFT isn't just about keeping the water clean. It's about taking that harmful waste and actively transforming it into high-quality, edible protein for the fish and shrimp to eat. It is the ultimate closed-loop recycling program happening right there in the water. So how does this amazing transformation actually happen? Well, it's not really magic. It's microbiology. And it all comes down to one absolutely critical principle: the golden carbon-to-nitrogen rule. All right, let's walk through this cycle. First, fish do what fish do. They eat, they create waste, and that waste is full of toxic nitrogen, mostly ammonia. So next, the farmer adds a simple source of carbon to the water, something cheap like molasses. This carbon is basically rocket fuel for a specific group of bacteria, and their population just explodes. These supercaffeinated bacteria then start gobbling up all that toxic nitrogen, using it to build their own protein-packed bodies. And finally, the fish and shrimp turn around and eat these little protein snacks. Waste becomes food. The loop is complete. The whole secret, the real key to making this work, is getting that fuel mix just right. The target, the magic number, is a carbon-to-nitrogen ratio of 15:1. That is the absolute sweet spot. It guarantees there's enough carbon to fuel the bacteria so they can consume all that harmful nitrogen, turning the whole tank into a non-stop, self-cleaning protein factory. Now, a system that cleans itself, produces its own food, and is radically sustainable? I know, it sounds a little too good to be true. And while the upsides are just massive, this is a high-performance system. And that means it comes with some pretty serious risks, too. But first, let's talk about the rewards, because, wow, they are game-changing. Remember that 20,000 liters of water? BFT can drop that to under 200. That's insane. The need for expensive commercial feed, it can be cut by up to half, because the animals are literally grazing on the protein being made in the tank. And because it's a closed system, it's a natural fortress against diseases. All of this can lead to a production boost of up to 43%. Okay, I know what you're thinking. A system that uses almost no water, makes its own food, and boosts yields that much? There has to be a catch, right? There's always a catch. And you're right, there is. First and foremost, a BFT system is completely dependent on energy. It needs constant aeration to keep those flocs suspended and the water oxygenated. A power outage for just 15 to 20 minutes and the whole thing can crash, a total system collapse. The initial setup cost can also be pretty high, and you're not just a fish farmer anymore, you're a microbe manager. It takes some serious skill. And if you don't get it right, excess sludge can build up and create toxic dead zones in your tank. Now, to put this all in context, it's really helpful to compare BFT to another advanced method called recirculating aquaculture systems, or RAS, and you can see the trade-offs right away. BFT has a lower price tag to get started, but you are managing a complex, living biological system that's on a knife's edge. One mistake can be catastrophic. RAS, on the other hand, is much more stable and mechanically controlled, but it costs a fortune up front and you get zero feed savings. But the story of Biofloc doesn't stop here. Far from it. It's not just a solution for today. It's actually becoming the foundation for the entire next generation of food production. So get this. The newest trend is to integrate Biofloc with aquaponics. They're calling it FLOCponics. All that nutrient-rich water from the fish tanks, instead of being a problem, is now piped over to grow plants like lettuce and herbs. It creates this beautiful, symbiotic, totally zero-waste system. We are harvesting both fish and vegetables from the same drop of water. And we are pushing it even further into what people are calling Aquaculture 4.0. All those high-stakes risks of BFT, we're starting to solve them with technology. So instead of a person doing manual water tests, now we have IoT sensors streaming real-time data. Instead of reacting to a disaster, AI models can actually predict an ammonia spike before it even happens. We're moving towards fully automated, intelligent farms that rely less on guesswork and more on precision control. All of which leads us to this final, kind of mind-bending thought. Biofloc technology really changes the game. It transforms aquaculture from just raising fish to actively managing a complex, invisible world of microbes. So as we search for truly sustainable ways to feed our planet, you have to wonder, is the future of farming actually about farming bacteria?